One Earth,
Many people.
Climate Change Abatement Strategies for Policymakers by Amelia Tan, Phua Hao Yu, Dhi-zen, and Yiting. To better illustrate our case, we will be using the A1B model from the Special Report of IPCC. This model we chose is the most realistic and agreeable because it allows for uninterrupted economic growth of all countries while minimizing the negative impacts on the climate by having a balanced emphasis on all energy resources. IPCC, also known as the Intergovernmental Panel for Climate Change, predicts that an increase in 2 degrees Celsius of our global mean temperature would lead to massive impacts on our ecosystem, water supplies, massive food shortage, as well as increased stress on our healthcare systems. Is this what we want for ourselves and our future generations?
No!
With the upper limit of 2 degrees Celsius increase in temperature to avoid, we can then determine the maximum permissible carbon dioxide concentration in our atmosphere. This can be determined using parameters defined by our model as stated earlier. This will then help us arrive at our answer of 450 parts per million. We can then substitute this 450 ppm into the Kaya identity to relate back to politically relevant indicators which would be of interest to all of you. Global CO2 emissions can then be represented by the equation shown here. The first term is a measure of carbon content of energy, the second is representative of the energy intensity, and the third of production per capita. Lastly, these three factors are multiplied against the global population.
Carbon content of energy can be reduced through converting to renewable energy sources. As of 2011, only 12.9% of global energy consumptions are met by hydro, nuclear and other renewables, and only 1.6% are met by other renewables such as solar and wind. This lack of usage is mainly due to the higher cost per unit of energy, the levelized cost of energy, or LCOE, of the renewables. This is termed as the alternative energy source, not meeting grid parity. But renewable energy sources will soon be able to meet grid parity as the price of oil increases and the LCOE of renewables decreases. LCOE of onshore wind is estimated to reach about $90 per megawatt hour by 2020, while the price of oil is projected to reach about $73 per megawatt hour. Although still more expensive, it will help reduce the carbon content of energy. Offshore wind speeds are much higher than onshore winds. This alternative source of energy is attractive but expensive. Small wind turbines with fitted wind lands are able to work in low wind speed conditions. They are also quiet, able to produce kilowatts of power, and are perfect for deployment in urban areas. These turbines are near the end of developmental stages in Japan. Photovoltaics harnesses the almost unlimited supply of energy from the sun. It houses the most promising future as an alternative energy source and can be installed modularly, be deployed in off-grid areas, has a single upfront cost, and usually has a lifespan of 20 to 25 years. Research into improving the efficiencies of the photovoltaic cells have been rigorous and have seen wonderful results. Current manufactured solar cells have an efficiency of 17 to 19%, and there is certainly room for improvement. Price of the solar cells have also fallen considerably, and with programs such as the Sunshot Initiative by the US Department of Energy to meet $50 to $60 per megawatt hour by 2020, it is set to soon enter the market at a very competitive price. About a tenth of the area of the Sahara Desert receives enough energy from the sun to power the whole world. It is a shame to not harness this clean and free energy. Any excess energy can also be exported to neighboring energy-hungry nations. The development of renewable energy sources have been impeded by cost. Now that cost is coming down, it is imperative that we develop them as soon as possible. If a tenth of the area of the Sahara Desert receives enough energy to power the world, then there is certainly a huge room for improvement. I ask you to nurture, grow this young industry, create jobs, build a pool of people with the expertise in this area of photovoltaics and solar thermal, so that when this technology becomes mature, you can fully utilize the technology. In Kenya, people have adopted solar power through solar panels and solar ovens, instead of hooking up to the electric grid. They then use the PV system to charge up a car battery to power lights at night. This brings up the issue of energy storage. As with what the Kenyans did, it can be scaled up to include smart grids. They are improving battery technologies and other energy storage methods, but they are still not cheap for the long-term energy storage. This is where nuclear energy comes in to form the base load for our energy source.
Nuclear power is an alternative power source that uses the nuclear fission of radioactive substance, usually uranium, to create heat and thereby through a heat transfer mechanism and turbines, create electricity. Nuclear power produces more clean energy in kilowatts than coal, wind or solar power for fewer cents. In year 2012, nuclear power plants provided about 5.7% of the world's energy and 13% of the world's electricity. There are several benefits of employing nuclear power. Firstly, lower carbon dioxide and other greenhouse gases will be released into the atmosphere in power generation. Besides that, the operating cost is relatively low when compared to other power sources. Moreover, the large power generating capacity of nuclear power plant is able to meet industrial and city needs, as opposed to low power technologies like solar power, which might meet only local, residential or office needs but cannot generate power for heavy manufacturing. In this graph, you notice that France relies largely on nuclear power for its electricity source after Lithuania. Surprisingly, US being one of the most industrialized nations in the world does not rely as much of electricity source on nuclear power as one would expect. Now, let us take a closer look at the second component of Kaya identity. Tons of oil equivalent over gross domestic product, in short TOE over GDP. This term is also known as the energy intensity. Energy intensity is a measure of the energy efficiency of a nation's economy. It is calculated as units of energy per unit of GDP. High energy intensity basically indicates a higher cost of converting energy into GDP, whereas low energy intensity indicates a lower cost of converting energy into GDP. As you can see in this graph, Canada falls in the last place in terms of energy intensity. This also indicates that Canada has low energy efficiency. Therefore, increasing energy efficiency and reducing energy intensity should be a policy goal for Canada and its peer countries as a way to mitigate climate change and conserve energy. For a sustainable energy future, Canada must encourage economic activity and GDP growth that does not rely on increased energy consumption. Italy, with its annual energy intensity of 122.8 tons of oil equivalent, is the most energy efficient country among the G7 and also one of the most energy efficient nations in the industrial world. This is mainly due to the traditionally high energy prices, which have resulted in more efficient companies and consumer behaviors. Here are a few feasible ways to decrease a country's energy intensity. Nation leaders can restructure the economy towards low-intensity industries that are also high value-added. Governments can try to boost the economic growth which increases faster than energy consumption. More importantly, energy wastage in all countries should be rapidly reduced. This can be done via cogeneration and trigeneration. Cogeneration, also known as combined heat and power (CHP), is the use of a heat engine or power station to simultaneously generate electricity and useful heat. As for trigeneration, it is also known as combined cooling, heat and power (CCHP), and it refers to the simultaneous generation of electricity and useful heating and cooling from the combustion of a fuel or a solar heat collector.
Hi Yiting, how can we use sex education in less developed countries to alleviate climate change?
Okay, so as you can see from the slides, the less developed countries are actually having much higher population growth compared to the more developed ones, and this is correlated with the higher fertility rate in the less developed regions. So one may think that less developed countries, right now they are not contributing significantly to the carbon dioxide emission, so why should we bother? Okay, so if you think about it, the less developed countries with a higher population growth rate, in the future when they have industrialization and more development, the higher population growth rate will amplify the negative effect of carbon dioxide emission on the environment. So we need to curb this problem right now and introduce sex education in these countries so as to alleviate climate change problems in the future.
Okay. How feasible are these strategies that you suggested in the real world?
Okay, so for these strategies, right, we can apply to our Kaya identity in two ways. So one of the terms that include population is the GDP per capita. So for that term, it is not very feasible that we want to cut down on that term because every country wants to increase their GDP over time. So we will focus our attention on the population term. And when we cut down on the population growth, actually every country can better focus its resources on the people to increase their education level as well as training. So this can improve the productivity of the nation as well as lower the population growth rate, and this can cut down on the carbon dioxide emission in the future.
Okay, thank you Yiting.
Thank you. After looking at how we can employ greener energies, reduce the energy intensity, as well as control population growth, we can reduce the left-hand side of the equation via sequestering of carbon dioxide gas. Apart from carbon tax, we can use the new biomass energy with carbon dioxide capturing and storage strategy. By using biomass as fuel, the biomass is able to first absorb carbon dioxide for photosynthesis during its lifetime. There are also other mechanical ways to capture and store CO2 from industrial processes. This can reduce the amount of carbon dioxide in the atmosphere, and the carbon dioxide emission is even predicted to be negative 2 gigatons per year in 2050, as estimated by the International Energy Agency in 2009. To sum up, we aim to lower carbon emission by relying more on renewable energies, improving energy efficiency, using sex education to slow down population growth, and using carbon capture and storage technologies. By taking a wedge approach, we can more easily convince the public to work with us in reducing the detrimental effects of drastic climate changes which will take place in a few years' time if we don't do anything about the situation. This also leads to a more responsible, empathetic, thoughtful, and cooperative world which is willing to compromise some of their own standards of living for a more sustainable Earth for the future generations. Thank you for your kind attention.